Welcome folks, and in today's lesson we're going to learn about the exciting topic of inertia and Newton's first law. Newton's first law being sometimes called the law of inertia, and we're going to call it something else by the time we're finished. A little graphic on screen here is Newton's cradle. We get that in there straight away. This is a good example of Newton's first law, where those balls will not move unless acted upon by that external force. So we're going to tease out what this means. So maybe a couple of questions just to get us started. What happens when you're driving along and suddenly slam on the brakes? Your car stops and your body does something else. You're stopped at a red light and the light turns green. You hit the gas. The car jerks forward and your body does what? So maybe take a second to pause the video and think about what would happen in those scenarios. So why? So this is the question that the great Galileo pondered way back when, maybe not to do with cars because of course they were not around then. And he thought of a specific scenario where a ball was rolling down the hill. And a ball rolls down an incline, and he supposed that it returns to the same height in the absence of friction. So if we take that friction out, the ball, he thought, well, it should return to the same height. It'll roll down the hill and return back to that same original height, that delta H. And then he thought of another scenario where we make that incline a little bit less steep, and where the ball rolls down the incline and it will return to that same height again. Only this time it will take longer. And then the true magic and genius of Galileo is he extended it further, and he asked himself, well, what would happen if the incline was made flat? So the ball will, what will happen? Will the ball ever return to its height? Will that ball keep rolling until it returns to its height? And what we now know to be the case is that that ball will actually keep moving. What he supposed was that it would keep moving if there's no friction. And that's really, really important because it leads us into an understanding of Newton's first law. And it also lets us know a couple of things. Without friction, the ball would continue moving at a constant velocity. Why is that? Well, we're going to introduce this concept of inertia. Inertia causes the ball to resist change in its motion. So that's what inertia means, this resistance to the change in motion. And we'll tease that out soon. And an object doesn't need a force to keep moving. That is very, very important. Up until that point, it was always assumed that a force kept an object moving. You might require a force to get moving, but not to stay moving. So what does this concept of inertia mean? Well, it is a property of matter, just like matter is anything that takes up space and has mass. So too inertia is a property of matter, and anything that has mass has inertia. And it causes an object to resist changes to its motion. In other words, if an object is at rest, like Mr. or Mrs. Potato there, then they will want to stay at rest, looking very comfortable. And if an object is in motion, it will want to stay in motion. So sometimes I like to refer to Newton's first law, the law of inertia, as the law of laziness. Objects want to keep doing what they were doing. And the other thing we should say about inertia is that it is directly proportional to the object's mass. The more mass an object has, the more inertia it has. And if you've ever tried to push an elephant recently, you would understand that. So Newton's first law of motion, if the net force acting on an object is zero, that means the total overall force, the object will maintain its state of rest or constant velocity. In other words, will keep doing what it was doing. So if we look at our wonderful cartoon yoga instructor to use as an example, we're going to put a mat or a floor underneath her, and we're going to look at the forces that act on that yoga instructor. Well, the force of gravity would act downwards. It's a vector, so we're going to show that with a green arrow. And we're also it's going to have a magnitude and direction, so 100 newtons down. And if the yoga instructor is not moving up or down, there's no acceleration, that would mean that there's no net force acting upon her. And in this case, we know that the normal force is going to act perpendicular to the surface, and it's going to act upwards. Now in this scenario, because the purple vector and the green vector are equal but opposite and cancelling each other, it means that there is no net force. So in other words, the net force is zero. In Newton's second law, we explore the fact that net force is tied to acceleration, and if the net force is zero, it means there's no acceleration. So when there's no net force, no acceleration, this yogi will keep doing what they were doing, in this case staying at a position of rest relative to the observer. So objects at rest will remain at rest unless acted upon by a net external force. Objects in motion will remain in motion at the same motion unless acted upon by a net external force. If the velocity of an object is zero, the net external force acting on it must be zero. And also if the velocity of an object is changing in magnitude, so there's acceleration, that means there must be a net external force on the object. These are all things that we can learn from Newton's first law. So hopefully this has cleared up a little bit of Newton's first law for you and helped you to understand that. Remember, it's important that you're able to show that with free body diagrams, FBDs. This scenario on screen here is a very typical example of where we put that into practice, where we would bang the ketchup and trying to get that sticky ketchup out. There are some other applications, some more serious applications, seat belts, which would keep your body in position rather than having your body move forward like it would continue to do in the event that a car hits something. Airbags and also concussions would be an example of Newton's first law. So I would challenge you to think of other examples of Newton's first law, and if you enjoyed this video, please remember to give me a wee thumbs up.